Thanks, Mike. So I showed my family the agenda this morning, and the consensus opinion was they had no idea why I was here among such distinguished speakers. I think I'm the token geek. I've been a faculty member at MIT my entire life, adult life, but I've had the pleasure of being engaged in a couple of things over the past few years that have really informed what I want to share with you today. As a faculty member at MIT, I've been fortunate to transfer technology out of my lab into a number of companies, and also have started some companies, some of which are manufacturing in Massachusetts. In addition, MIT led an activity called the Production in the Innovation Economy, which was a collection of 20 university faculty from across the institute: economics, political science, management, science, and engineering. And we spent the past 2.5 years basically drilling down on this question of, is our ability to innovate intimately linked to the existence of a production ecosystem around us? And our answer, perhaps not surprisingly, is a resounding yes, it's very important, but we hope to have put some quantitative underpinnings around that statement. And lastly, MIT participated very actively in the Advanced Manufacturing Partnership Program, which was launched by the Obama White House in the summer of 2011. We worked closely with them to develop a set of recommendations, and it's really delightful to see that the White House has embraced those recommendations. And I'm sure Roger's going to talk about those next, but some of the activities that have come out of that, I think, are really exciting. So let me first talk about the production in the innovation economy activity. As I mentioned, it was a group of 20 faculty members. What we did basically is we surveyed over 1,000 manufacturing firms nationwide. And these were extensive surveys and phone interviews to basically get into the details of how they innovated and how that was linked to their manufacturing capability. We went out and interviewed 250 firms across the U.S. as well as around the world, focused largely in Massachusetts and Ohio, but also 36 companies in China, 35 companies in Germany, and basically try to understand some of the things that drove their manufacturing processes. So what did we learn? Let me share a few things, and then there's a common thread. One thing we did was we looked at Main Street firms. So these are firms which we, through a database search, identified firms that had doubled their revenue in the period of 2004 to 2008. Doubled the revenue in a 4-year period and increased their headcount. It turns out in the US that if you filter out for firms that are only 5 million in revenue and greater, that's 3,600 firms roughly that have doubled the revenue in a 4-year period, and these are manufacturing firms. You ask, how did they achieve that success? How did they double their revenue? And there's 3 things that really came through. One was they were able to tap into a local ecosystem that enabled them to move quickly. The second thing was many of them engaged in highly innovative partnerships, be they economic development board activities, be they partnerships with local community colleges or universities to help enable what they do. And the last thing was, which was interesting, was that they evolved their business so that service was an important part of the component of the product they delivered. And that's something we see as a really strong thread, which is really champion manufacturers are evolving so that service is a major part of their revenue stream to couple to the manufacturing. What are the challenges? Well, as I think we all know, since the 1980s, we've seen a loss of the vertically integrated large manufacturing firms. And this has been a result of the capital markets recognizing that capital efficiency leads to greater shareholder value, and you see firms pivoting from being fully vertically integrated to shedding all but what they consider to be their core competencies. When that happens, when a vertically integrated firm in a region does that, it hollows out the ecosystem of suppliers and entities around them that allow them to do that. And that loss of that ecosystem is what has challenged most of the manufacturers in the US we have found, and it's this evolution in the corporate structure. I think it's also, one of the companies we studied and we were very excited about was Timken Corporation, and it's a little intimidating because just about a month and a half ago, Timken is a publicly traded $5 billion company in Canton, Ohio, manufactures tapered roller bearings, they also have a steel plant. And they have that steel plant because it allows them to develop new innovative tapered roller bearings. Unfortunately for them, an activist shareholder entity basically pushed through a vote for divesting the steel business from the tapered roller business because it would enhance short-term shareholder value. And so I think somehow we have to get folks to understand how this linkage of these capabilities enables innovation and in the long run is important for companies. We studied the labor issue, the so-called skills gap. I think the conclusion there is that most firms are not having difficulty finding workers, but there's a cohort, about 25% of the firms we studied, that have sustained difficulty in finding employees, and those tend to be some of the most innovative firms. And those employees they're trying to find are the ones that you wouldn't be surprised by. They're highly skilled machinists, skilled in precision machining. We also studied startups, and in particular what we did is we looked at MIT starts up about 10, 20 companies a year. Interestingly enough, 75% of the companies that spun out of MIT in the past 10 years were manufacturing firms. So we looked at those 150 companies. What did we learn? Those companies basically take a long time when they're making something to get that product into the market. Typically 10 to 15 years from the bench invention to revenue generation. They are challenged in finding late-stage capital, and interestingly enough, one of the most common sources of late-stage capital for these firms is foreign investments. A company that spun out of my laboratory called Lilliputian Systems in Wilmington, Massachusetts, makes a portable solid oxide fuel cell device which is used to recharge your mobile phone. It's a technology we invented in my lab 15 years ago. Brookstone will start selling it this summer. The last round of financing for Lilliputian was led by Rush Nano. And associated with that investment was a commitment to do some activities in Russia. Now, happily for us, Lilliputian's product is actually being manufactured in a clean room in Hudson, Mass. That Intel operates. And what was critical to Lilliputian was, again, the ecosystem. So the punchline for all the work we've done on studying this linkage of innovation manufacturing is that firms can move fast when they have a robust ecosystem around them. And I think that's really what's critical, and I think that's what's important about what's happening in the Advanced Manufacturing Collaborative. And I think it's just terrific that everyone is here today to roll up their sleeves and work on this, because I think we could do some great things here by strengthening that ecosystem. From my perspective, looking ahead, what excites me at MIT, though the research opportunities are really phenomenal, and I think it's about researching around the barriers. So why is it that we're challenged to manufacture in the United States? Well, people talk about labor costs, people talk about energy costs, people talk about the cost of capital, and the fact that some regions of the world are willing to subsidize access to capital to draw manufacturing to their shores. And lastly, the time it takes for us to take ideas and make them into products. And in each of those areas, we see exciting research opportunities. In labor costs, some of the transformative things around human-assisted robotics, really exciting and will no doubt change things. Rethink Robotics, a $20,000 robot, is a really exciting concept in terms of pushing some of that capability into firms. Energy, it was mentioned earlier this morning, the fact that we are seeing a decline in the cost of energy, and that's going to change some things. But there are some exciting manufacturing technologies like biosynthesis that can replace high-temperature processes and lower the cost of energy in manufacturing. But the thing I wanted to conclude on is education, which is that one of the things that we learned through the Advanced Manufacturing Partnership is that we do face a challenge in educating workers, skilled workers in the highly innovative manufacturing firms. And I want to share with you an anecdote, which is that about in November of 2011, we held a workshop at MIT associated with the Advanced Manufacturing Partnership. We heard, and maybe that person is in this room, but we heard from the president of a precision machining company in Nashua, New Hampshire, came to the microphone and implored community college leaders to train more folks skilled in CNC machining. That basically this individual was concerned. Everybody that was doing that in his plant was graying, and he didn't know where he was going to get his next cadre of CNC machinists. No sooner had he made that statement and sat down than the president of Upstate New York Community College stood up and declared that he had to cancel that class last month because he didn't have enough people in the class. And that was followed up by 2 weeks later. We had a visit from former Governor Strickland to MIT, and he was proudly describing to me the work that Ohio has done in their community college system. And what struck me like a thunderbolt was that community colleges tend to be optimized around reducing commute distance. If you're going to use a community college, you're doing it between a day job and taking care of your children and other commitments. And so that time to get to the campus is the challenge. And so this is a fundamental problem. If we're going to train skilled workers through the community college system, which we need to do, but we can't fill the seats, we're not going to solve it by increasing the density of community college education. So what's the solution? Well, one of the things we're doing at MIT that we're really excited about is something that we call MITx, which is an experiment in online education. Now, there's an acronym called MOOCs, Massively Open Online Courses, and you'll hear a lot of hype about it. It's a little bit like 3D printing. There's an awful lot of hype, but there's actually a lot of substance behind it as well. And in the case of MOOCs, I'll give you a story, which is we taught a class last year. 6002 is the class. It's called Circuits and Electronics. It's one that I taught a number of times. When we offered the class online, 150,000 people enrolled in the class. Now, by the time it was done, all the tire kickers dropped out. But in the end, 7,000 people completed the class. This is more students that we trained in one semester than we've trained in 20 years on campus at MIT. 7,000 students got an MIT Circuits and Electronics class. And the interesting thing is we did it with the same teaching staff that we teach 200 students on campus with. You say, how could that be, Marty? Well, the way it could be is when you watch the discussion board of this class, we told the TAs, if somebody posts a question about a problem, don't answer it for an hour. And what happens is somebody else who's taking the class answers it for them. And then a few weeks later, somebody posts online and says, hey, I'm in Bangalore and I'm taking this class. Anybody else in Bangalore taking this class? Well, 8 people raise their hand and they start meeting at Starbucks on Saturday to do the problem sets. I'll tell you another story, which is we took that class and we did a partnership with San Jose State. San Jose State used to offer that same class. The pass rate on that class was about 55%. It's a very challenging class. We took the class and did this flipped classroom model where you watch the lectures in your dorm room and then you come to interact with the professors and learn. The pass rate for San Jose State went from 55% to 91%. So there's hype about this, but there's substance. And it's very exciting, and I think we have to figure out how to take this educational revolution and roll it into some of the challenges that this industry faces. And we're working with the state and other partners to define what I'll call manufacturing X or make it X or whatever you want to call it, but basically think about a flip the shop model where we'll develop the online curriculum, but then these folks can go to maybe some of your company's facilities to access some of these tools and get the necessary hands-on training. So let me just end by saying we're tremendously excited that this gathering is happening. MIT's committed to this. We think the opportunities are really fantastic. And our future as an innovative institute is tied to your existence and your success. So we really want to work closely with you. Thank you.